is the Investor Connect podcast program. This is Hall T. Martin. I'm the host of the show, in which we interview angel investors, venture capital, private equity, family offices, and many other investor groups for startups and growth companies. I hope you enjoyed this episode. Thank you for joining us. Let's move on to our next presenter. We have with us today Barry Fella of Cranial Devices. Barry, if you could launch your slides and kick off when you're ready.
I got really thirsty after that last presentation, so let's do that. So medical devices, in particular, we're going after fixing a pretty good-sized problem in the medical world for treatment of hydrocephalus, which is, you don't know what it is. It's too much water in the brain. And how it's treated is you stick a rubber tube literally down the middle of your brain and drain it down into your abdomen. The problem with that is the failure rate is incredibly high. First year alone, 40% of the patients who get one of these things will have to have a re-intervention, re-operation within the first year. The cost associated with that alone is $1 billion. The overall cost to the health system is about $3 billion annually. The problem with these things is that they fail. They get infected, they clog, and if they siphon, they can literally pull too much water out of the brain and kill you. It's a lifetime disease, and patients can survive their whole life, a normal life period with these things, but you're going to have, on average, 10 revisions in your lifetime. Some people have had well over 30. All right, so what we're doing is totally different. We're doing something called physiologic shunting. So we are taking that same excess water, the CSF, and we're draining it into part of the venous system. And we do that all right there on the cranium. So we don't have any of the problems associated with the longer rubber tube elements. It's about a 15 to 30-minute procedure to do this. So right now, the current market for hydrocephalus shunts in the US is about 170 million a year, doing about 100,000 surgeries per year, which 70,000 of those are revision surgeries. So worldwide, it's about a $500 million market. If a more reliable device is invented or brought to market, it will immediately capture 100% of that revision market. That's, again, these failure rates are so high that they're just unacceptable, and that's the way it's been for 50 or 60 years. The device will be what we call a Class 2 de novo. That's the guidance that we already have from the FDA. IP is well in place. And it's got a worldwide application for all forms of hydrocephalus. You don't need a specialized skill set other than being a neurosurgeon. You don't need to have navigation, robotics. It's nice, but not needed. It's very easy training how to do it. As I said, about a 30-minute procedure time, and you have multiple locations on the cranium where you can place it. We have one competitor out there. They're doing what's called an endovascular technique. Ours is a surgical technique. Ours is basically just faster, better, safer, cheaper. That makes it easy, and you don't need specialized training to do it. They raised about $124 million for their effort. We have raised $2.5 million to date. We are looking to raise another $2.5 million via convertible note to complete our task for 2025. That sets us up to do our first human pilot. We are well into our animal pilot studies now, and we'll do what they call a GLP study a little later on in the year. So as I said earlier, it just got downright better performance than what's called a ventricular peritoneal shunt or brain to the stomach. And it's just far safer. It's no bridges burned kind of an implant. If it doesn't work, you take it out, put another one in easily through a skin incision. So it's fast to implant. We can do it under local anesthesia, low cost of goods, no special instruments. And as I said earlier, it will immediately capture that revision market because it eliminates all of the failure points that I mentioned earlier. And everybody in the user universe here will benefit: patients, surgeons, hospitals, and payers. And that's it. I can go into some other market opportunities, but let's find out first, I think, if you have an interest in this.
Great. Thanks, Barry, for a great presentation. Nola, what's your first question?
Well, hydrocephalus is usually found at the beginning of life. Is that true?
No.
No, it can happen at any time?
Yes, it happens. It can happen spontaneously. It can happen because of trauma, because of surgery, infection. Meningitis can cause it. Infants, yes, they probably, in the US, probably are 15,000 of those 30,000 primary implants in the year.
Do you need anything to be guided using ultrasound or anything in order to do your insertion? It's pretty simple, huh? You know.
Simple, it's just anatomical landmarks. You have suture lines, the same sutures you had when you were a baby. They get
Right.
fixed when you get to be about 5 or 6 years old. And that's all the navigation that you need.
And how are you going to sell this cranial device?
It would go through medical device distributors. We're going to get bought out. I mean, Medtronic and Integra currently own 92% of the market. They sell $5,000 valves that continually fail. There is no need for a valve with our system. So if they want to stay active in the hydrocephalus market, then they're going to want to take this.
And and does it need FDA approval?
Yes. Oh yeah. But it's
Where are
class
you?
2. It's not class 2 is 510K. It's not a PMA, which could be 7 to 10 years. We will be through the FDA probably no later than 2028.
Okay, and you're gonna go the 510K route?
Yes, it's 510K, but when you do a de novo 510K, you have to do a certain amount of animal studies and human pilot studies. So it's like a PMA, but with a much shorter timeline and much shorter follow-up periods.
Have you had a pre-IND meeting or
And
anything?
we've had 2 of those.
Okay. And so you feel like you know what you need to do to get the data that you need?
Yeah, we're well down the path of getting the data that we need. The animal data that we're doing now sets us up to do what they call the IDE, investigational device exemption, that allows us to use it with humans. So that would be then for the human pilot studies. The human pilot studies, just because the FDA is historically very slow, we'll be doing those either down in South America or Australia. And the first human pilot studies is only going to be 5 humans. And with this device, you know within an hour whether it's working or not working for you.
Yeah.
And the total follow-up period is 3 months. So we have the pilot study will be very short compared to what's required for a PMA.
All right. Thanks, Noah. Vadim, what's your first question?
I don't know. The exit sounds like it's 2028 or 2029.
I don't know if it'll be that late.
Ah.
That's when, it's on its own kind of thing. The exit, the way it works in the medical device industry, 15 years ago, they bought technology. Now they want to buy sales or study data. That's where they want you to be. Once you've proved that you're safe, and again, the FDA, believe it or not, does not require that we have efficacy. I mean, it's really hard to believe, but we will be. And our device is a very simple device. It has no moving parts, but it has a very solid IP portfolio around it. And probably the biggest thing, and again, I've been in medical devices for a long time, is there's a guaranteed market waiting right now today for these revision patients, because this is an awful life to have to continually have surgeries. They know they need revision. When their eyes start crossing, they get massive headaches. They can't walk straight anymore. And if you don't do something about it quickly, they die.
Yeah.
So a revision is not an optional thing. They have to be revised. And what we're hoping to do is stop that train.
How do clinicians view this new technology? Is it a change to their process? Does it require special training, or what's their
Nope.
view on it?
They use a burr, a surgical burr, which they use all the time in their normal practice. That's it. I mean, there's no special tools. It's not really special training. It's unique training, but it's not very challenging.
Question from the audience: where is production going to be done?
In the U.S.
Okay, you've already found a certain supplier contractor for it. Okay.
Yeah, we in our animal studies, we are using human devices in the animals. So they meet all of the standards of sterility and other device tests.
Have all trials been in the animal model?
Yes, in the sheep model. That
In the
is
sheep model?
the go-to model. It's not a great model compared to a human, but it is the gold standard for the last 40 or 50 years.
Okay. Any other questions from the audience here?
Well, let me just, one other thing I'm going to throw back at you real quick is the other market opportunity is something called normal pressure hydrocephalus for people over 65. Currently in the US, we get about 700,000 patients diagnosed with NPH. Only 1% of those are getting shunts, even though shunts work. And the symptoms there are dementia, gait instability, and incontinence. And when you shunt those patients, those symptoms go away. So you have a form of dementia that is fixable. It is a huge market, and that's our competition is going after that market, where our decision is we'll let them develop the market and then we'll step into it.
Yeah, one more question from the audience. How was it hydrocephalitis created in sheep?
Well, they do it two ways. One is they inject a solution of kaolin clay and saline right into what's called the ventricle. And then that usually will kill the sheep within 24 hours if not treated. And sheep are fairly sensitive creatures that way. We actually use a harder model where we don't create the hydrocephalus with clay. We do it with a sheep that is normal pressures, normal intracranial pressures. And that's a very, 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 very low flow condition. And that is actually the most challenging for our device. And we've done it both ways. And it's an easy surgery.
Okay. Noah, do you have any other questions?
Well, I'm curious, you sound like you're looking at that shunting market for dementia and old people, which is going to be big. Are you going to do any work in that? Or are you just going to go?
Oh, yeah. No. It's the same exact device.
Yeah.
So the question there is, well, where's that market today? Because only 1% of all those diagnosed patients are getting shunted.
Right.
The reason they don't get shunted is you don't want to put an implant in an 80-year-old, only to have to do it again and again and again. And you don't want to do something that requires general anesthesia on an 80-year-old. So the fact that we can do this under local anesthetic, right? And it's just literally, it's just below your scalp. If something didn't work or needed to be fixed or whatever, you just slice it open, pop the implant out, put another one in. So it has great interest from all the neurosurgeons that we've been working with. I mean, it doesn't mean anything for them to say it, but they say, I do it tomorrow, because they look at it and say, they can see how it is not going to fail, because we've eliminated all the failure points of the current shunts.
Not only is it not going to fail, but it sounds like it might work better.
Oh my God. Yeah. Yeah. Again, I've been in the med device industry for a long time. In the orthopedic industry, you might have a 3% failure rate. We're talking 40, 50, 70%, depending on the patient group with shunts. And that's been going on since the late 50s.
Yeah.
Great. We have two more questions from the audience, and then we need to move on. How do you prevent clotting in the brain?
Those are kind of
Drained. Yeah.
in the drain.
Drain, yeah.
Ours is a constant flow device. So when you stop flow, that's when you can create or get clotting to occur from other cellular material that might be in the CSF. So our design is specifically designed to flow all the time, but it's self-regulating. It works on the CSF is always at a higher pressure than the venous system. So there's always a pressure differential. So as your intracranial pressure comes down, then the flow slows down.
Okay. And what has been the cause of early device failures?
Clogging and siphoning is the number one.
Siphoning. Okay.
If you can imagine, you got a water bed, you're on the third floor, you're going to drain it. It'll drain really fast because that's siphoning pulling it. You drain it from the first floor, it'll take hours. So every time you stand up with one of these old-fashioned rubber tubes, you're setting yourself up to siphon and then overdrain the brain.
Okay. And one more question. Any offshore human use?
Not yet, no. That hopefully will be about December, January.
December, January? Okay, great. Oh, well, one more. Even in normal pressure hydrocephalus, is there no clotting?
You can always get clotting, but even if you do get clotting, you don't want to make it a major operation to revise it. And literally, it's like a 2-centimeter skin incision in 2 screws, and you just pop the implant out and put another one in.
Okay.
So
I think that's it for the.
Yeah.
I think it's it for the questions, but I'll offer certainly a great opportunity to come to the breakout rooms to ask more on that one. So Barry, if you can make the breakout rooms, that'd be great. We have one more presentation and then a presentation on terms. With that, let's go and move to our next presenter.
Investor Connect helps investors interested in startup funding. In this podcast series, experienced investors share their experience and advice. You can learn more at investorconnect.org. Paul T. Martin is the director of Investor Connect, which is a 501c3 nonprofit dedicated to the education of investors for early stage funding. All opinions expressed by Hall and podcast guests are solely their own opinions and do not reflect the opinion of Investor Connect. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions.